Welcome to Placement Season, India's #1 placement preparation site. Wednesday on air webinar session are open to everyone who is in need of right placement guidance. Today we are going to discuss on how to prepare for database management system and SQL part. This is one of the most important topics for your exam. Mostly you will get multiple choice questions from this part. Out of 20 MCQs, you can expect around 10 questions from this topic. So learn this topic very well. Let's take a look on today's agenda. First, let's do a quick recap of previous week's webinar session on InfyTQ certification exam. Second, we will discuss on how the course is structured in InfyTQ website. Third, let's discuss on few concepts of DBMS. Today we are going to focus mainly on normalization topic. Finally, let's discuss on sample MCQs which you can expect in InfyTQ exam. So before moving on, let's do a quick recap of InfyTQ certification exam. As you all know, InfyTQ is a technical exam conducted by Infosys for the freshers. The exam duration will be 3 hours. You will get 20 MCQs and 2 programming questions. The weightage of marks distributes as 40% for MCQ and 60% for coding. You should get at least 65% to pass this exam. The questions will be based on 4 foundation courses, which includes Python, DBMS and SQL available in InfyTQ website. So after you clear the InfyTQ exam, you will be called for HR round. If you clear the HR round, you will be posted as Systems Engineer with 3.6 lakh per annum. Then there will be upgradation exams as well. If you clear the upgradation exam, you will be placed either as System Engineer Specialist or Power Programmer, depends on your score of upgradation exam. For the Power Programmer position, the salary package will be around 7 to 8 lakh per annum. Okay, what happens if you clear the technical exam but you cannot able to clear the HR round? Don't worry, you will be provided with certificate from Infosys. This certificate can be used for your other interviews as this proves your technical skills. Here comes the important update. Screening tests are going to be conducted on February 10th. I repeat, screening tests are going to be conducted on February 10th. The duration will be of 1 hour. You can expect questions from Quants and Python fundamentals. Please check with your placement coordinator for more updates. Next, we are going to see how the DBMS and SQL course is structured in InfyTQ website and how to prepare for the exam. Open this link and register with your email ID. So after you log into the InfyTQ website, you will be finding foundation courses available here. The other 3 foundation courses are missing for the past few days. Maybe some issue with the website. We will let you know if we get any updates on this. Today we are going to see DBMS and SQL part. So when you open, you can see the course description. It is to learn and understand the basics of DBMS and SQL. So if you give start over, you will see the table of content. They have given the day-wise schedule from day 1 till day 10. The course has been structured really well. So spend time on each topic and learn the concepts. So they covered the concept. First they gave the introduction about database, data integrity and constraints, and then about the entities and relationships diagram, ER diagrams. After that, they have covered SQL basics, like the basic commands and data types. Then DDL statements, which is data definition language. In this section, you will see how to create a database, how to create a table, and drop table, alter table, all those things. After that, data manipulation language. So you have your tables ready, and in this section you will see how you can insert data and how you can retrieving the data, updating data, deleting data, all those things. So after that, the functions available in DBMS. So how can you get the required information from the available tables? So using functions, sorting data, grouping data based on your requirement. After that, the most important concept, joins. So you will have your data across many tables. So if you need any information, you may need to join few tables to get the required data. So inner join, self join, outer join, and then about subquery, transactions, modular query writing, normalization, which we will see in detail, and then about the index, how the tables are scanned, all those stuffs, and then the NoSQL database. Under this, you will be seeing the MongoDB, all those things. And then you have your practice test. And then finally, you can take the assessment. So as we cannot able to cover all the topics, we will concentrate on a few topics in today's webinar. So we will check on the additional concepts, functions, sorting data, and grouping data. So till here, you will know how to create a table and how to insert the data into the table, and the basic operations like how to retrieve the data, updating the data. And now we will see some functions available in SQL which will help you to retrieve the data efficiently. So under each topic, since it's a database concept, you may need a backend table to perform some example. So once you click setup data, the backend table will be populated. So here I see page data is refreshed. Okay. So first, under SQL functions. So as I already said, SQL functions are built-in modules provided by a database. So you can use them in data manipulation statement to perform calculations on data. So data manipulations in the sense insert, update, all those statements. So first, they have given about single row function and multi-row function. So single row function, it operates on a single row and it returns a single row. What is multi-row function? Multi-row function operates on multiple rows and it will result in a single row. So some of the commonly used single row functions, here you will be using it in select, where, class, order by, and having. And multi-row function again select, order by, and having classes. Let's look at an example to understand what is single row function and what is multi-row function. They have given a table, employee name and salary. So in this column you have two names and they have given salary. So this is a inbuilt function, upper of employee name. So that will convert the lowercase letter to uppercase letter. So this function works on a single row. So it will result in James Potter and Ethan McCarthy in uppercase letters. So it produces one row of output for each row of input. So this row corresponds to this row and this row corresponds to this row. So this is a single row function. Then when it comes to multi-row, when I want to find the sum of the salary, then it involves multiple rows to produce just one row of output. So the salary column, the summation will be displayed as an output. So multi-row function produces just one row of output irrespective of the number of rows of input. So then they have some inbuilt numeric functions. You can go through this one by one. Like in other languages, ABS, this will return the absolute value of your number. Round, seal, floor. So you can check each one of these functions with the example given here. And similarly, we have character functions. Upper, lower, concat, length. Upper, it will convert value to uppercase and lower converts value to lowercase. And then this is for concatenation. And length, it returns the number of characters in values. So you can use this drop down to see the concept with sample query and the query output. So we have few quizzes. So which of the following statement is false about function? Single row function always works on single column. Multiple row function returns multiple row. So this is wrong because multiple row functions also return single row and single row function always works on single row, not single column. So this is false, this is false. Single row function returns single row. Yeah, this is right. Multiple row function works on multiple rows, but it returns single row. So this statement is also correct. So you can submit and check your answers. And this quiz is to check your understanding on round, seal, floor, all the numeric functions available. Check on this. Okay, so we have seen a numeric function, character function, numerical function. Now we will see the character functions. So here we have one more character function, substring. So it is used to extract part of a string. So you have, if you have a input as database, then substring of database comma 5 means starting from 5, it will extract the letters. If you don't mention the length, it will extract till the end of the word. So in this case, database comma 5. So index starts from 1. So starting from 5, it starts extracting. So base will be the output. So starting from 3 and then length of 3. So starting from 3, 3, 4, 5. So the answer is tab. So next comes the conversion function. So it is used to convert data from one format to another. So to character, it will convert number to a string, and to date, it will convert string to a date, and to number, it will convert string to a number. Okay, here is another quiz. What will be the output of the following query? Select length of substring of last name, 3, 7 from customer. First, let's check the output of this substring function. Last name of 3, 7. So here, starting from index 3 till length 7, 3, 4, 5, 6, 7. So the output of substring of last name, 3, 7 will be SOUZA from the input disauza. So what is this length? The length will be 5. So the length of substring of the using given condition is 5. And then you have few more quizzes. So practice these quizzes to understand the concepts well. So we have seen single row and multi-row functions, numeric functions, character functions, conversion functions. Then comes the date function. We have sysdate, systimestamp, add months, months between. And then comes the most important function, aggregate function. So aggregate function, it operates on multiple rows to return a single row. Some of the common aggregate functions are sum, average, minimum, maximum, and count. So here sum and average, it works only on numeric columns, while the other functions minimum, maximum, it operates on all data types. So this is the important point. All aggregate functions ignore null values except count of star. So here they have given an employee table as an example with column ID, employee name, salary, bonus, and department. So first let's check these functions, minimum, maximum, and sum. So select minimum of salary, maximum of salary, and sum of salary. So we are going to check the salary column. So minimum of salary will be 25,000, maximum is 90,000, and for the sum it sums all the salary and provides the output. So similarly for count with distinct. So distinct gives the unique count. So select count of department as count 1, count of distinct department as count 2. So where is the department? So if you just count the department, it will be 1, 2, 3, 4, 5. And if you count only the distinct part, that is unique department name, then it is ICP and ETA. So the count will be 2. So you have a quiz. Which of the following aggregate functions can be applied on both number and character typed? So we have already seen minimum, maximum. Okay. Here the count also can be applied on both number and character typed columns. Okay, it's right. Okay, another example. There is a table T with a single column A. A column has 4 rows with values 100, 200, null, 300. What is the output of the following query? Select max of A from T where A greater than 1000. So If you ignore the var class, select max of A from T will return the output 300. Now we have the condition where A greater than 1000. So from the given table, none of the values are greater than 1000. So we may think this maximum of A from T may return no rows. If you submit, the answer is wrong. So since you have null value here, it will return null as an output, as it ignores the null value. We have already seen. And then miscellaneous functions, NVL and user. This NVL of value 1, value 2. So it substitutes value 1 by value 2 if value 1 is null. The given condition would be both the values should be of same data type. So if value 1 is null, then the value 2 should be taken. So in this case, you have a table weather. So here select city and then NVL of city, not available. That means if city name is not present, if city name is null, then you take the output as not available. And then one more condition. NVL of minimum temperature, not available. If minimum temperature is not available, then you have to output as not available. In this case, this not available, value 2 is string. So you have to convert the value 1 also to string. So you have this conversion function, 2 underscore character of minimum temp here. So here you have an exercise. Let's do one exercise and move on to the next topic. Write a query to display product ID, product description, and category of those products whose category name is electronics. Do case insensitive comparison. That means ignore the case. You have to consider both uppercase and lowercase. Just the name should be electronics. So this is your input table. So we are going to query on this category column. So this should be the expected result. That means we should print the category column which has electronics. So one naive approach would be, as you know the output already, you can write the query as select product ID, give the correct column name, product ID, product description, category from the table name is product, where category is either equal to electronics with full of uppercase or category equal to, as you already know the value in the input table, we can write this type of query. So you got the required output, but there are logical error. So now in this case, there are only 2 columns which has electronics like this. Suppose if you have like 100 rows with electronics upper and lower cases mixed in each of the columns, then we cannot write a query like this. So now we can use the inbuilt function. So instead of this, we can write it as, so you know the upper function, right? So the upper function will convert the case to the uppercase. However it will convert all the case to the uppercase. So now we are converting the category into the uppercase. Now we are checking with the keyword. So now if you verify, our query is right. So similarly, you can try lower function also. So in this case, you have to change this to electronics in lower case. So that means it converts the category value to lower case and then it compares with this keyword. So that's how we can use the function. So similarly, we have many exercises. Try all these exercises to get to know the concepts. So till now, we have seen how the course is structured in InfyTQ website. And we had also discussed few topics. Likewise, you go through all the topics and understand the concepts. Practice all the quizzes and exercises. Now we are going to discuss about normalization concept. You will definitely get an MCQ from this topic. So, normalization is a process of organizing the data in database to avoid data redundancy, insertion anomaly, update anomaly, and deletion anomaly. Normalization divides the larger table into the smaller tables and links them using relationship. The normal form is used to reduce redundancy from the database table. So we have many types of normal forms. The most common forms are first normal form, second normal form, third normal form, Boyce and Codd normal form, which we can also call it as 3.5 normal form, and fourth normal form, fifth normal form, and so on. Today we are going to discuss on first three normal forms. So the first normal form deals with atomic values. That means a relation is in first normal form if it contains an atomic value. It states that an attribute of a table cannot hold multiple value. Attribute meaning column. So a column cannot hold multiple values. It must hold only single valued attribute, which is nothing but atomic values. First normal form disallows the multi-valued attribute, composite attribute, and their combination. It creates a separate row for each set of data. So let's look at an example for better understanding. So this is a sample staff table working in multiple departments. If you see, the table has three columns: name, age, and department. So for the first row, for the name John, he works in two departments, both mechanical and combustion. And then the second row, Dave, he works in electronics department, and Hazel works as a manager. If you see in the first row, in the department column, there are two values in a column. So this violates the 1n form. So if you want the table to satisfy the first normalization condition, then we need to divide it into two rows. So for each department, we are creating a separate row. So we have a row John, age 35, and mechanical department as one row, and for combustion we have another row. So by this we make sure we are dealing only with atomic values. So a relation is in NF only if it contains an atomic value. Then let's move on to second normalization form. Second normalization form deals with composite keys and partial dependencies. So for the table to satisfy the second normal condition, a table should already be in first normal condition. So a relationship will be in 2NF if it is already in first normalization and all the non-key attributes are fully functionally dependent on the primary key. That means there should not be any partial dependency. So to understand the partial dependency, first we should know what is composite key. So for a table, if it has more than one column as its primary key, then we can call it as a composite key. If any of the attributes depends on only a part of the primary key, then it refers to partial dependency. For the table to be in second normalization form, this partial dependency needs to be removed. Let's look at an example. So we have a table with HOD ID, HOD name and department. So a single person can be HOD for two departments. So for the HOD ID 1, the HOD Edward, he is taking care of both biology and zoology department. Similarly, for HOD ID 2, he is taking care of both physics and chemistry department. So from this table, we clearly understand it is already in 1NF. So it has only atomic values. So here, the composite key will be both HOD ID and department. The one more column HOD name, it depends only on HOD ID. That means it depends only on part of the composite key. So this violates the 2NF, second normalization form. So for this table, to satisfy the 2NF form, we divide it into two tables. So for the first table, we have only HOD ID and HOD name. And for the second table, we have HOD ID and department. So with this, we remove the partial dependency. So if you see the advantage of table to be in 2NF is it reduces data redundancy. For example, consider a table before 2NF. That is the first table here. If you want to change the HOD name for HOD ID 1, suppose if you want to change the name Edward to Johnson, then you need to change in 2 rows. But after second normalization form, if you want to change the HOD name Edward to Johnson, you just need to change it in the HOD ID table, HOD information table. So with this, we can easily reduce data redundancy. Next, let's see third normalization form. It deals with transitive dependence. So a relation will be in 3NF if it is in second normalization form already and there should not be any transition dependency. So no transitive functional dependency for non-prime attribute on any superkey. So what is non-prime attribute? That is the attribute that is not part of candidate key. That is nothing but the primary key. Let's look at an example for better understanding. So consider a table. It has book ID, genre type, and genre price. So here book ID is a primary key. So the genre ID depends on book ID. But the genre type does not directly depends on book ID. It depends on genre ID. Genre ID depends on book ID. So indirectly genre ID is depending on book ID. This is transitional dependency. So for the table to be in 3NF, this transitive dependency needs to be removed. So we will have two tables, one separately for genre ID and genre type, and another for book ID, genre ID, and price. So third normalization form is used to reduce the data duplication. It is also used to achieve the data integrity. So things to remember, for the first normalization form, it deals with atomic values. The second normalization, it is to remove partial dependency, where composite keys comes into picture. For the third normalization form, it reduces transitive dependency. Hope you understood the concept of normalization. Discuss on few sample MCQ questions, which you can expect questions in this format for your exam. So the first question, consider the following code written for creating the table. So this is the syntax to create table. Create table and then table name. Here the table name is account. And the columns are account number, account name, and balance. For account number, the data type is integer. For account name, it is varchar. And they have also mentioned not null constraint. That means the account name should not be null. And then we have a third column, balance, in which the data type is not mentioned. The table is not getting created. Identify the reason. So option A, balance must be not null. Account number must be not null. Primary key is missing for account table. Balance must have a data type. So the constraints are optional. The not null condition while creating the table is optional field. So option A and B ruled out. And also primary key declaration also not mandatory. So the answer would be option D, balance must have a data type. So for all the column, data type needs to be mentioned. Let's move on to the second question. Rajesh created a table employee in order to record employee details. The table creation script for the same is given below. So create table employee, employee ID, data type number, primary key, and employee name varchar, and cabin number, and again the number. And here we have given constraint unique. That means the cabin number value should be unique. Currently table has some data as given below. So we already have some data in the employee table with employee ID 1001, 2 and 3 and employee name and some cabin number also. So the question is, if you want to insert another row, what is the right option? Let's check option A. Insert into employee values with employee ID 1004 and the name and the cabin number 789. So the first two fields are fine because 1004 are not yet inserted in the table. For the primary key column employee ID, the name also fine, but the cabin number 789 is already in the table. Since we declare cabin number as unique, we cannot insert another 789. For option B, value 1004, the name, and then null. Okay, this looks fine. And then option C, the first column has given us null. Primary key cannot be null. So this will fail. And for option D, if you see the first column value 1003, which is already present in the employee ID column. Since employee ID is declared as primary key, we cannot have duplicates in that column. So the option would be B. Let's move on to the next question. Consider the below table salesperson. We have sales ID and amount. And we have some DML statements. We are selecting distinct ID, amount from salesperson, order by amount, ASC means ascending. So we need to get the distinct, that means unique ID and amount. The combination of ID and amount should be distinct from the table salesperson, and we need to sort the results by amount column in ascending order. Based on the output of the above query, identify the correct statement. So, for the given query, the output will be the second table. That means you first find the distinct combination for ID and amount. So the combination would be for 1002 2400, for 1005 1800, and for 1009 600, and so on. So this result should be ordered by the amount column in ascending order. That means the amount 460 will come first, and then 600, and then 8800, and then 2400. So let's look at the option. So 1005 will be third record, and 1009 will be fourth record, and so on. So from the result, it is clear that option A is correct. Let's move on to the next sample question. Okay, here comes the question related to normalization concept. Consider the following relational schema along with functional dependencies. There is a table, order details, which has the following columns: order ID, date ordered, quantity ordered, item number, item name, item price, customer ID, and customer name. So with this detail, it is clear that this table has too many information. Like it has information for orders, it has information for item, and it also has information for customer. So there are too many dependencies. Then they have given the relation: order ID and item number. So quantity order depends on order ID and item number. And then customer ID and date order depends on order ID. Item name and item price depends on item number, and customer name depends on customer ID. Or we can say in both the ways. The question is, what would be the resulting relational schema after converting to third normalization form? So we know for third normalization form, first the table should be in 2NF. That means there should not be any partial dependency. So indirectly, it should be on 1NF also. It should have only atomic values. And then for the third normal form to be satisfied, there should not be any transitive dependencies. So keeping in mind all these things, let's check the options. So they have divided into 5 tables in most of the options. So let's look at the first option. Table A, order ID and customer ID. And table B, order ID, item number, quantity ordered, item price. So here if you see both item number and item price is present, that is fine. And for the table C, item number and item name. And for the table T, customer ID and customer name. And table E, order ID and date ordered. So here, if we see, in most of the table, there is data redundancy and there are dependency. For example, the table E, order ID and date ordered. In this case, we should have customer ID so that we can relate order ID with customer. Okay, let's look at the second option. Table A, order ID, customer ID, date ordered and customer name. Both customer ID and customer name are present. It is not necessary. It will result in data redundancy. And for the table B, order ID, item number, quantity ordered. And for table C and item number and item name. For table D, customer ID and customer name. So here also we have some dependencies. Let's look at the option C. So first table, order ID, date ordered, it is fine. Table B, order ID, item number and quantity ordered. And for table C, item number, item name. Table D, customer ID, customer name. Table E, item number, item price. As we already discussed for like option A, the first table has only order ID and date ordered. Here the link with customer is missing. Let's look at the option D. So it is more or less similar to option C. The only thing is the table A has customer ID included, order ID, customer ID, date ordered, and table B has order ID, item number and quantity ordered, and table C, item number, item name, and table D, customer ID, customer name, and table E, item number, item price. So the answer will be option D. And here, if you see the item number and item name, item price, it is divided into two tables to remove transitive dependency. If we have all the three columns in the same table, then item price will not directly dependent on the primary key item number. It depends on item name directly. Item name, which in turn depends on item number. So this will lead to transitive dependence. So we have two tables for items. Then let's move on to the next question. Consider the tables product and orders with the data as follows. Product ID, product name and cost, and we have order table. Choose the query which will generate the output given below. They have given the output. If you see the output, they have taken product ID 1001 and 1003. And when you see the quantity, so for each product, they have taken only the minimum quantity. That means for TV, if you see in order table, TV is product number 1003. We have only one, so it is fine. For mobile, P1001, in order table we have two entries, one with quantity ordered 10 and another with quantity ordered 5. They have taken only the minimum of 2, so 5. And also they ignored product 4, PC. So with this in mind, we can write query like select product ID, product name, and we take only the minimum of quantity ordered as quantity. So we are joining both the tables on product ID, and then we are grouping by product ID and product name. So the output will be mobile TV and PC with quantity 5, 1, 20. But in the given output, PC is missing. That means we are restricting the quantity value. Let's check the option. So yeah, we have the minimum of quantity ordered greater than 10, less than 10, like that. So if you check all these options, the correct option would be product ID, product name, and then minimum of quantity ordered from the table, and we have join, and group Y. We have a function having minimum of quantity ordered should be less than 10. So for this query, we will have the given output. So in this webinar series on InfyTQ preparation, we discussed on 4 foundation course in detail. Please check the previous week's webinar series for more details. So the key here is learn the concept well, practice more. There is no substitute for practice. First practice without timer, then practice with timer. By following all this, definitely you can able to crack this course. So here in placement season, we have restructured preparatory course for Infosys Certification exam. So the link is given in the description box on how to avail this course. And also now we have 50% off on this course by using promo code InfyWeb15. Please check the description box for more details on how to avail this course. So let's see how the course is structured here. So here we have learning content, practice test, and assessment. This learning content has all the concepts explained, and then we have the practice test without timer, and then we have assessments with timer. So make use of this platform to prepare for this exam. So hope the session is informative. If you have any doubts, please write us to friends@placementseason.com. All the best for your placements. Thanks for watching. Bye bye.